Proposition 4. If a straight line is cut at random, then the square of the whole straight line is equal to the sum of the squares on the pieces of the straight line and twice the rectangle contained by the pieces. For let the straight line AB have been cut at random at point C. I say that the square on AB is equal to the sum of the squares on AC and CB and twice the rectangle contained by AC and CB. For let the square ADEB have been described on AB from proposition 1.46 and let BD have been joined and let CF have been drawn through C parallel to either of AD or EB from proposition 1.31. And let HK have been drawn through G parallel to either of AB or DE from proposition 1.31. And since CF is parallel to AD and BD has fallen across them, the external angle CGB is equal to the internal and opposite angle ADB from proposition 1.29. But ADB is equal to ABD since the side BA is also equal to AD from proposition 1.5. Thus, angle CGB is also equal to GBC, so the side BC is equal to the side CG from proposition 1.6. But CB is equal to GK and CG to KB from proposition 1.34. Thus, GK is also equal to KB. Thus, CGKB is equilateral. So I say that it is also right angled. For since CG is parallel to BK and the straight line CB has fallen across them, the angles KBC and GCB are thus equal to two right angles from proposition 1.29. But KBC is a right angle. Thus, BCG is also a right angle. So the opposite angles CGK and GKB are also right angles from proposition 1.34. Thus, CGKB is right angled. And it was also shown to be equilateral. Thus, it is a square. And it is on HG, that is to say on AC from proposition 1.34. Thus, the square HF and the square KC are on AC and CB respectively, and the rectangle AG is equal to the rectangle GE from proposition 1.43. And AG is the rectangle contained by AC and CB, for GC is equal to CB. Thus, GE is also equal to the rectangle contained by AC and CB. Thus, the rectangles AG and GE are equal to twice the rectangle contained by AC and CB. And HF and CK are the squares on AC and CB respectively. Thus, the four figures HF, CK, AG and GE are equal to the sum of the squares on AC and BC and twice the rectangle contained by AC and CB. But the figures HF, CK, AG and GE are equivalent to the whole of ADEB, which is the square on AB. Thus, the square on AB is equal to the sum of the squares on AC and CB and twice the rectangle contained by AC and CB. Thus, if a straight line is cut at random, then the square on the whole straight line is equal to the sum of the squares on the pieces of the straight line and twice the rectangle contained by the pieces, which is the very thing it was required to show.